All right, guys, we're going to try something a little new. I'm recording this at school, so if you hear announcements pop up in the background or somebody knock on the door, that's where that background noise is coming from. So here is our first lesson for Unit 4, and it's talking about plate tectonics. So we're going to be talking about earth science for now. So, just a reminder about how the Earth is composed. The Earth is made of many layers. The outermost layer is the crust, which is solid rock. There are multiple types of crust. Continental crust is generally going to be thicker and it's going to form the continents and various land masses. Oceanic crust is what's found underneath the oceans. There's various differences between them. They tend to be composed of different rocks and minerals. And oceanic crust tends to be denser, which is going to come back in a little bit to be relevant when we talk about some of these plate boundaries. So, within the Earth, you have the lithosphere, which is the rigid outer layer of rock. You have the asthenosphere, which is the partially molten layer of rock that's below the lithosphere. This is kind of a boundary between the lithosphere and the mantle itself. Part of the crust does contain asthenosphere. The mantle is the next layer underneath, and that is very viscous, which means very thick, kind of molten rock. It's molten, meaning it's melted, and that means it's a liquid, but it's a super thick liquid. So when it flows, it's going to do so very slowly. And then finally, at the core, you have a metallic layer, so heavy metals that have kind of sunk into the center of the earth. And the rotation of these is what creates our magnetic field, which is very important because it actually protects our atmosphere. So here we see our crust is made of, we have here oceanic and continental crust. Our crust is made of the lithosphere as well as the asthenosphere. Below that, you have the mantle, and then underneath that, you have the core. And so, what we're talking about is the theory of plate tectonics. And remember, in science, a theory has a lot of evidence behind it. It's not hypothetical, it's theoretical, meaning it's something we're fairly certain about. So the lithosphere, which is that solid kind of outer crust, that solid rock, is broken into multiple plates, kind of like the picture I have here of an egg, where if you have an egg that's been hard boiled and it's cracked, if you had an egg with many cracks, that would be kind of like the surface of the earth. And so these plates that are making up the lithosphere are moved around because they float on top of the layer of magma in the mantle and the asthenosphere. And that movement of plates lets them slide either into each other or past each other or away from each other. And that creates plate boundaries. Plate boundaries are where some of the more interesting things tend to happen as far as surface features of the earth. And we're going to talk about that when we talk about each of these types of plate boundaries. So, just a note, just as ice floats on water, solid rock floats on magma. So that's how these plates are able to kind of move around. They float on top of the magma and they're carried by currents in the magma. So we mentioned plate boundaries. Let's talk about the different types. You have convergent plate boundaries where they come together, and that is going to create some surface features like mountains, some island arcs. It can also lead to earthquakes and volcanoes because as these plates come together, they hit each other. That can cause some disturbances in the Earth's surface. So if you have two plates of equal density, usually continental plates that are coming towards each other, that's going to create a mountain. If you have plates of different densities, like here, that's going to create what's called a subduction zone, where the denser plate is going to sink underneath the less dense plate. So, subduction zones are formed generally a lot of times where oceanic crust runs into continental crust. And the denser oceanic crust sinks underneath the lighter continental crust. It gets melted, and as it melts, it starts to get less dense and rise, and that magma bubbles up and then create chains of volcanoes. So that's why when you see kind of along the boundaries of continents, you may see some arcs of volcanic ranges. That is due to the boundary between an oceanic and a continental crust, where they are converging on each other. Orogenesis is what happens when two continental plates come together. That is going to be the formation of mountains. So, a really big example of this is the Himalaya Mountains in India. Here in the Indian plate is actually moving up into the Asian plate, and that that collision of these two plates is creating the Himalayas, which are actively growing, which is why the tallest mountains on Earth are generally located in the Himalaya mountain range. A divergent plate boundary happens when two plates are moving away from each other. This can cause things like seafloor spreading, which is what you see in this GIF right here, rift valleys, and then you can have all the usual things that happen at plate boundaries like volcanoes and earthquakes. So when you have two plates move away from each other, that tends to expose the magma that was underneath, and so that also tends to be where new land or new crust is being formed. So, a rift valley is a special type of divergent boundary that happens when two continental plates are separating. So, up here, this is the East African model of the East African Rift Valley. So, you see these two plates are moving away from each other. And as they move away from each other, the area in between ends up getting filled with an ocean. So, there is a part in East Africa, an area where you have this divergence in these two plate boundaries moving apart, and that is eventually going to become an ocean. Transform boundaries happen when plates slide past each other. What's going to commonly happen is you're going to have a lot of earthquakes there. And you have fault lines formed there. Like here, you see a very famous fault, the San Andreas Fault in California, because the southern part, this kind of southwest portion of California, is actually on a separate continental plate from the rest of North America. They're sliding past each other, and as they do, a lot of earthquakes happen. This is an area where a road was built crossing the San Andreas Fault, and when an earthquake happened and the land shifted in a kind of slightly sudden manner, when there was an earthquake, the road actually kind of got offset because of the plates sliding past each other. And so over time, people have mapped these different plates. These are the biggest plates, the major plates. There are some smaller ones, but a tectonic plate map will show you where most of these plates are located. So notice, for example, I pointed out the Indian plate, which is moving up into the Eurasian plate. The Pacific plate contains that southern part of California, which is moving up while the North American plate moves down, which is why the southern area of California, and I think like 50 million years, is going to be an island off the coast of North America. And these kinds of maps are very useful because they can be used to show where you're likely to have volcanoes, some island arcs develop, earthquakes, hotspots, faults, things like that, so that you can try to predict when you'll have this tectonic activity like earthquakes and other things that can have large impacts on people. Earthquakes, by the way, happen when you have a fault line or plates moving, and stress kind of builds up because rock is rough. It doesn't slide past other rocks smoothly. So sometimes it kind of catches, and then energy builds up as those rocks are still trying to slide past each other, and it gets released very suddenly. When that happens, that release of energy is an earthquake. There are a couple of important terms. The focus or the hypocenter is the origin of the earthquake, not just where on the surface it happened, but earthquakes can actually happen kilometers underneath the surface of the earth. The epicenter is the point on the Earth's surface directly above the hypocenter. That's where you're going to probably see the largest impacts on the surface, where you'll have the strongest kind of vibrations from the earthquake and probably the most damage as well. Seismic waves are the wave energy from this energy release that traveled through the earth, and these are going to cause damage on the surface. They can be caused not only by earthquakes, but you can have volcanoes or landslides or large explosions can also release seismic waves. So sometimes there'll be like a large landslide underneath the surface of the ocean, and we'll record that fact by noticing the seismic waves that are generated. This is a map showing the epicenters of about 358,000 earthquake type events between the years of 1963 and 1998. What you'll see is most of these tend to be clustered along plate boundaries. So if you map these earthquakes and other tectonic events, you kind of get a map of the plate boundaries themselves. There are a few exceptions. For example, this area right here, that's a hotspot. That's actually what formed the Hawaiian Islands. Um, and you'll see a few isolated places like out in the center of the Pacific, which is right in the middle of a plate. Earthquakes, by the way, are measured on the Richter scale. It measures the intensity of the earthquakes, and it's a logarithmic scale. What that means is that an earthquake that is a magnitude of 1 is going to be 10 times stronger than a magnitude of 0. Um, a lot of earthquakes actually happen that aren't strong enough to be felt if they happen at a low enough scale. Something on the Richter scale at like a 3 or a 4 is big enough to be felt, but it's probably more of a gentle vibration. Anything that's 7 or 6 or above is going to have a lot of vibration, a lot of movement on the surface, and is likely to cause a lot of damage. All right, there goes that set of notes. Get ready for some more.